Okay. Welcome. I guess we let the countdown go. Awesome. Let's get started. Today, back again at the debugger. Though today we're working on the line number program debugger because I was running into bugs. Let's see if I can do this. VDB. Yes, let's just run this. See, we'll hit invalid line number program right here. We're getting a delta minus 71 on the line where it's resetting the line register of the state, but currently the state's at 66, and so it's not valid. And so I want to go through and build out a line number program debugger. So I'm building a debugger for my debugger code so that I can see what's going on. So currently what I have is this. Oh, nope. That's the same command I just ran. lnpdb. And you can see what it does. It just displays the raw bytes of the line number program section. So this is actually the header. And then I think the header is only, I think the header ends right around here or somewhere, and then it begins. And you get the line number program, and then we can see what happens on the side. Now, right now, we don't have actually any of the, I don't have any of the stepping ability. So that's actually what's next, is to build in stepping through the line number program. And so what we're going to use is our code from dwarf data here in the line header. Got dwarf line header. That's not what I want. I want the line number program actual code. Line number program. And what I'd like to do is we have this advanced standard opcode, advanced extended opcode, advanced special opcode. And we have this read. And so I'd like to have write my own step function that takes in these. And all I need is the header, the state, and the opcode. That's easy to get because the opcode is, you just read through, you get the header. Yeah, what we'll basically do is recreate some of this code, but we're gonna mark these as pub for now. Pub and pub. Actually, we don't need that to be pub. That's all I need there. And so you need to mark those as pub, and then dwarf.zig. I'd like to line number program pub line state. So what we actually probably want to do is this. Where we get the state, we want this to be line rug.state. But actually what we probably want to do is go back to here. And change this to be line rug Yeah. And then do this. There we go. That should be good because now what we can do is step through. What we want to do is have a step function or a thing that allows us to step. So we need to keep track of, I think the current opcode would be good to track. Maybe in the app view, we have the data model. That keeps the header and the state. Maybe we just put opcode here. I want to keep it here. Do it here for right now. Might move this around. And we'll call that a U size. Hmm. And actually, you probably want to do something like opcode type equals const. Draw this down here. Opcode type. And that's just gonna be enum. And we'll have advanced. No. Yeah, advanced, special. No, it's extended. Extended, special, standard. And opcode type is a type. Okay. And this could be 0, default, and standard. Not standard. Okay. Because when we begin the, actually, I guess what we could do is interpret right here. When we start this, we have the data view, we're building the views out. So build out views. Okay. We have the line header here. What we'd like to do is get the seek here. We need to see line program offset equals should equal offset line number set plus LH header dot seek. Line program offset. Now it doesn't like what I've done. Seek instruct line number programmer header line reader. Okay, let's see if that broke anything. Nope. Okay, but it does change where we start. You can see this value isn't the same anymore. It starts at 0, 1, 0, 1, 1, F0, 1, A4. So now do want to, we have that started. we need to get the initial opcode, initial opcode, const initial opcode is going to equal, and let's just look at this stuff here again. So when we read through line number instructions, the special opcode, header, directories, all right, content descriptions, line number program, as stated before. Each byte special opcode has the following effect on the state machine. Add assignment. Yep. All of the special opcodes do the same thing. They differ one from another. Okay, special opcode. If the resulting opcode is greater than 55. Okay, so we just gotta check what kind of opcode it is. So initial opcode. Let's write a little block here. I think if we do something like this, const initial opcode type initial opcode type equals that's how it works. I think it actually works this way. There we go. Okay, and what I'm gonna do is one standard. Okay. Lock. Okay. And that will go into the data view. We can do opcode to opcode initial opcode and dot opcode type equals initial opcode. Okay. Now we will take a look at this. Let's see. Oh yeah. So we want to calculate this. We want to switch on the first byte, which is going to be debug line program offset. Debug line program offset. What we really want to do is at int from enum. Enum from int enum from int as dwarf. Let's see, dw. Is it dwarf.dw lns Really? No, it's not exposed in this one? Interesting. Okay. That should be up here. Pub const dw equals at import dwarf w.zig. Okay. Oh, this needs to go down here. Okay. Now DW should be there and LNS. Oh, LNS is lowercase. Okay, yeah. And I can do this. Extended 0x00 because that is correct. It should be extended opcode. So then we can say dot extended um, oh, you know what? We don't need all that. We're just gonna do this. 0. Extended. Yeah, read. So what we do here is we take the opcode and we get that opcode value. Take the byte. If the opcode is greater than opcode base, this unconditionally handles all special opcodes, including opcodes that would regularly be considered standard opcodes. That's true. We need to do that. So really, like if we just copy this logic here, let's just do that. Okay, but we don't need that. What we need is we don't need to do this. What we need to do is if opcode is here, we're going to log all these. That is fine. Okay. If opcode is greater than opcode base, then this is an extended opcode. Or no, this is a special opcode. There we go. Opcode does not take that. Opcode is just line, what is it? Debug line, debug, break, block. A break block. What? Code is going to be debug, line, debug line, line program offset. And the standard is going to be, this would be special. Okay. Else if it's a standard, else if it's 0, then this is an extended opcode. And that is going to be debug line program offset +1. And fs is special, extended. And otherwise it's going to be this fs standard. We're not going to log all this. Let's do opcode equals this. Reach header.base. Okay. That is great. What is failing? Type void cannot be destructured. Value with comp time only type. Enum literal depends on control flow. This is a deep, what is that? We got opcode type. Switch must handle all positions. Well, okay, did I make a mistake? I must have deleted something here. Yeah, I did. Discard that. Do I have a, let's see, get signs? Reset hunk. There we go. Oh, that's right. I added a 0. This should be what's it called? Extended. This should be unreachable. There we go. There we go. Make sure everything works still. Okay. So what I want to do is, now that we have some data around here, I'd like to store in our data and our view, I'd like to view it. Let's see. So right now we view this fields there. Let's add through 2, right? 2. And then what we'll do is basically do this. Text format, let's see. Upcode, actually just do one more view. Code data is code text equals um, do upcode text. We're going to do try context dot arena dot alloc. Well, no, I want to alloc print. Dot arena format. Text should be opcode. We'll put that as an X hex value, and we'll put T here, and we'll do the data is going to be rather than be state, probably just do data dot upcode, data dot upcode type. And we need to add that text to a text view. So we do text views. This one equals text equals text. Children children lane equals origin equals row equals, we'll want a space between these, so we'll put a children length call equals 0 and surface equals try text. See, up code text dot, so we don't need text use. We're gonna do it anyways. Opcode text dot draw ctx. Expected type this, found pointer. Oh yeah, it should be a pointer to it. Name function print. Standard dot format dot alloc print. That right? And used argument. Oh. Okay. And there we go. Expected I-17 found U size. I-17. Okay. Children, like I know. Oh, yep, it's text use opcode 1 standard. There we are. Perfect. 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 Okay. Let's save this. For that, and I think we changed this. Let's see. Yeah, we want to stage that. And let's see, I think we also modified this. Yeah. No, actually. To add you know what? Don't need that to be there. What we do need is beat get opcodes to print in LNPDB. Okay, next thing we need to do is go back to here. Now we got that, we need to start implementing our step functions. Right? So we get the initial opcode and the initial opcode type. What we do is step through the functions. See how it's going. We can see the state change as we go. Yes. So what I'd like it to do is when I push in, so I switch on the opcode type and then perform whatever function it needs to do. So like advance that. So let's see if we do dot, and we probably need to keep track of C. Before I get really far into this process, let's put this in the app view right here. Yes. Oh no, yeah. This is perfect. Okay. If B dot matches in, we don't want it to do anything else or no other things with it. We just want to go step to next step to the next function. Or step to next opcode. switch app dot data model dot opcode type, and we'll do extended standard special step special. Okay. Okay. We need to write these functions here. So let's just put these down here. Through to step extended. I'm imagining that takes some opcode. We need step extended, probably take some current opcode. Do app.data model.opcode. Needs to take a state, probably. App.data model.state. Yeah. And I think for that is it for now. What we want is, though, a pointer to it. Pointer to both of these, because then we'll be able to modify them after we do them. So we'll be able to modify them in place. Let's jump down to here and take a pointer to some current see opcode. You know what? It's not the job of this one to modify the opcode. Current is the job to modify the state, but not the opcode, and that takes usize and takes a state object. Okay. Extended opcode. So here's taking an allocator and a reader and a header. Oh, we probably need the header too. We'll take a look at that. Why is it needing an allocator? Here it's reading uweb. Don't need to do that. We will need to handle errors here. Let's see. Let's eat them from int. It's getting the opcode, which we already did. Okay. I gotta get more water. I'll be back just a bit. Five minutes. Let's do it. Let's take a. I gotta take a. Yeah, 10-minute break here at most. More water. Be right back. All right, I'm back. Could have done 5 minutes. Just worried it was gonna take long. Fork AFK. There we go. And we're back. Okay. So if I remember right, what we were working on was, oh yes, porting this over. Okay. So first with extended opcode, you got to get the, count the instruction bytes. And we don't need to read the uleb. What we need to do is uleb 128. Yeah. uleb 128. And it gets the bytes, yes. Actually, I don't have to handle layer here because what we do is take the state, the buffer, this takes this and it returns the struct t and a count, const count, which actually we don't really care about right now, but actually we do care about it because we need to advance the opcode. Or we need to advance something. So then opcode is interesting. I forgot the extended opcode. Is that right? Extend opcodes. All right, these have multiple byte format. The first byte is 0. The next bytes are an unsigned leb. And the number of bytes in the instruction. The remaining bytes are the instruction itself, which begins with U byte extended opcode. So we really want this opcode thing to work here. This is wrong. What we really need is let's see, count op bytes equals dwarf.read uleb, not read uleb, just uleb 128 u64 const k u32. Okay. And then we go to read that. Delta. Maybe better just turn this into a reader. Read the uleb. Yeah, we'll just do it this way for right now. And going to how many bytes there are, and then we're going to read the next byte, which is a U byte. So the opcode, so op equals debug line program offset +1 plus count or plus delta. I need that count to know how far to go in the next when we advance the extended opcode to be able to know where we are. So what we really need is to turn this into union, and extended is a struct have what's the extended going to be, a call it should have length u32 and an opcode u8. Well, we just call it lne dwarf.dw.lne. You know what, we're gonna make this a dwarf.dw.lns. And this special is just going to be a U8. Okay. And now all of a sudden we just need to make this opcode. And data model opcode. Okay. And what we do is this. Up here, when we're getting the initial opcode, we don't need the initial opcode type. What we just need is opcode equals block. Yeah, this unconditionally handles all special opcodes. So opcode in this comment should be down here. Opcode equals debug line program offset. If opcode is greater than line header, what we really need is dot special equals opcode. I think that is right. And then here, extended opcode count bytes. Extended equals count what is it? Count bytes. And opcode equals opcode. And then here we have dot extended dot standard DC at enum from int opcode. Okay. So now what we get here is we need to send in the opcode. Which is this, and we basically what we do is skip our current pointer. Opcode, which is a oh, you know what? We could just do this too. So doing it all in here, what we need, yeah, instead of up here, step. Takes a opcode, opcode. Should return a new opcode. Okay. Okay. Yeah, we're gonna do this. Okay. Opcode. Take my hand, baby. Okay, and we need state. For sure, we need state. We also need the header. We need a pointer to state. Okay. Oh, we need the bytes as well. Okay. It's opcode takes. Yeah, get the opcode. What we really need is enum from int. We don't need to do this. We need is to do enum from int opcode dot opcode. Strict with a, what's it called? Lane, which is U32, and an opcode, which is a U8. Opcode. Okay. Does when it gets to padding. So if it's 0, yeah, we still do the padding. So we don't need to do anything here to the state. It's a no op. In sequence. You know, it might be worthwhile if the header just had like a program reader. Instead of passing the bytes, we just pass the program reader, because then we could just that data model or the bytes model. I would think that that would be the bytes model. is an IO dot reader. Okay, and what we want is, instead of that, what we want to do is, I'm jumping around here, but we'll get this working here soon. Passing the bytes, we're going to pass the reader. IO dot reader R. And what we do is we don't need to append any data. State is in sequence equals true. So what we need to do is at the end of this, we reset the state. This assumes that all target machines are either this, so address, size, header, address size, yep, int buff, take. Okay. Just say this is on, yeah, reader take. Address size A, address, break address, min. State that because updates the address. Okay. Define file. It's invalid. RTOS. Set discriminator. Okay. All right. So we do that. Seems pretty good. This should fail an error. Invalid. Yeah. Okay. All right. Oh, yeah, step standard. Okay, let's make the next one. Step standard. Then step standard. And what do we get? I think step standard probably needs everything that this one needs. Okay, except for that, this should be a standard opcode. Code, and really it should return an opcode. Let me fix this one first too. Okay. This needs to return opcode. so what we need to do is get next opcode. Okay. And then get next opcode. Okay, we got, let's take in a reader, and a header. So I'm going to turn in optional opcode. And what I want to do is take this and what we'll do is return null here. Return null. What we do is initial opcode. What we do is, instead of doing initial opcode, what we're going to do is reader. R dot take byte dot reader. Actually, if it can't take a byte here, it should just return null, right? Yeah, I still might have an io.reader.error. But here is catch return null. No, XP, there we go. And this unconditionally handles all special opcodes. Opcode is greater than opcode base, break special opcode. If opcode is 0, const bytes delta log.error unexpected at panic. Unexpected opcode. Okay. Const C. Yep. So then what we need to do is actually do dwarf dot read uleb. R. But we do need that delta. No, count bytes. We don't need this delta at all. We do read dot. Okay. So what this will happen is we read count the bytes. op no, r dot take byte catch return error dot invalid extended opcode. Else break this standard. Yep. Okay. That should all work. So get next opcode. What we really want to do is up here. Next. Get next opcode, and it should be LH. LH reader and LH header, which is a bit redundant, really. Actually, you should say or in header. Okay. Need that. Okay. Okay, step special opcodes. Const FN. I don't think we did step standard. No, we didn't. Surprised that's not erroring out. I'm probably just not getting there. Okay. This also needs a opcode. Code. This one needs a header. Line header. Yeah. Needs a state. To state, and it needs a reader. R. Guess it should be a pointer to an IO reader. And it's going to return an opcode. With an error. Invalid extended opcode. For sure. Valid. It will also need to return possibly invalid extended opcode. Right. Yes. When it's reading the next opcode, it might get an invalid extended opcode. Okay. All right. So what we need is to go to here, standard opcode, and just copy all of this. Yank. that there, opcode, or see, op equals at, what is it? Enum from int opcode. Oh, no, opcode should be, see, this should be a dwarf.lns, in which case we could just do opcode like that. Dwarf.lns should be a pointer to state, pointer to a line reader, and a pointer to a line header, and a pointer to a reader. Actually, I don't think we use the reader here. We should, though. Yeah, we'll need it to read the next. It's data, we don't care about things here. We're just going to set that. Wharf.readulab r catch invalid standard opcode state address plus equals header instruction yada yada. A way to break these up. And we truncate that. Okay. Delta. And then all look fine. Advanced special opcode. Yeah. And step special. Step special. There we go. And we get const buff here. We read the int debug info Indian. This would be do this const info equals at import built in. And we should do info.arch target.arch. Count instruction bytes. Standard opcode. Oh, opcode. That would be opcode.length. Okay. Return next. Get next opcode R. Header. Is that what they need? Yep, header. Okay. U8. Sure, that's U8 and decode opcode, header, and then return get next opcode R header. Okay. Oh, okay, and this should be just header. So blocking all that, we're just gonna return all these. Return return. Okay. Program reader. Program reader equals LH reader. Okay. Whew. Think. I think it us. Pretty close there. Okay. Expected opcode found that. So let's see. no error field opcode type. Switch opcode, see app.data opcode.step. Needs to take a if data model the opcode p oh my goodness, there we go. I just stupidly forgot how to write all my stuff up. Step. Okay. Yeah. All right. And what does it expect? Expects an opcode, state, header, reader. App dot data model dot state. App dot data model dot header and app dot data model bytes model dot program reader. Okay. Expected pointer to an op. Oh, we don't need a pointer to an opcode. We need to, yeah, const is fine. Expected IO reader found type. We definitely need a pointer to an IO reader. Okay. LNBD opcode ignored. Oh, yeah. Well, we need to definitely update the op. We need to do app.data.model data model opcode equals op.step. No field opcode type. Okay, yeah. So now we need to write a print function for this. Sun. Let's write a format function for this. Fn format pub format perfect. And what we want is a to do this switch self writer see extended do like this. Writer.print. I'm going to print, maybe I'm going to print opcode. I'm going to print C. Tag X. Extend C. LME dot. Yeah. T. Length is X. We'll do enum from int self dot, what is it? Oh, up dot opcode opcode op dot lang op dot lane. There we go. Okay, that's how you do extended. Let's do dot standard. Should just be a simple lns dot t x. Writer dot save dot print. Here we want to print what? Print up. Okay. And then dot special. W.print special. And we probably want, actually what we want to do is this. Special B X X there X for that, 0x in front of that, x in front of that. And we should probably do 0x 0 2. 0 2 2. Okay. Then we do up. Okay. No format for optional. So we do need to check to make sure that wherever we're printing this, opcode state header R. Opcode state header R. Actually, it should be up. Upstate header in R. I know we're trying to print. Where is it again? It's in data model. Tries to print it down here. Yep. So const opcode text equals if opcode if data.opcode op op. Code text. Break. Okay. Else. No opcode. Okay. Struct. Step extended. Okay, I need to name this struct. Const extended extended. There we go. Opcode extended. Okay, expected type T found T. All right. Expected type, integer type, find dwarf L and E. Okay. Found expected type IO reader. Expected type T found pointer to T. Expected type T error LNPDB found T. Did I? Expected type LNP opcode found error extended opcode. This returns an optional error. See, invalid. Extend opcode, invalid. Invalid standard opcode. Op step, try op step. Okay, and return step special. Expected pointer to DOI program. Oh, state found line number programmer header. Did I put these in the wrong order? Yes, I did. Header. Error opcode, standard opcode, and error extended opcode. Enum from int must have known result type as, but actually this is fine. Try. Valid format string, format per type. Format string 0x02. Oh yeah. Okay, take byte. There's no. Oh. A field name count. Aha, yes. Because I changed the name. I already tried to change the name once. I really didn't do very good at it. U32 found, expected U32 found end of stream error. Where is that at? 49? Try catch return error dot invalid the dot code. Okay, that is done. See if that changes anything. Oh, you know what I need to do is the app, when we do this, I need to consume and redraw. There it is. It's working. It's working. Padding length 0. Padding length 818. Bwomp crash, which is expected. Padding should be the end. Oh, I'm so happy with that. That is awesome. I'm gonna have to close today, but thank you for watching. If you watched, I'll see you next time. Happy coding.